A period of time can exist between the finish and start, or a lag between the two activities. For example, the concrete slab must be completed prior to installation of the interior studs, as the slab needs to be cured and hardened before framing, labor and equipment is on the slab. The contractor could insert a 5-day lag, allowing allowing the slab to cure for a week prior to installation of the framing. So next sequencing type of the activity is the start to start. So two activities may need to begin at the same time, such as installation of carpet and resilient floor covering with the same subcontractor installing both, but using separate crews. A lag might occur between the two starts as well. As an example, drywall installation may have a fairly long duration, such as 20 working days. Drywall, however, will begin in a certain area and progress away from that area. Some areas will be ready for painting 5 days after the start of the drywall operation. Time would be wasted if the painter waited until all of the drywall was completed. So the relationship then would be a start to start with a 5-day lag, with painting beginning 5 working days after the drywall. Obviously, coordination is necessary to ensure that the painter knows where to begin and that the area is clean and ready for the painter when scheduled. And the next relationship, finish to finish, is used when two activities should be completed at the same time, despite the fact that they might have different durations. So, logical sequencing, however, is most important in planning and scheduling. Care should be taken to ensure correct sequencing with the necessary activities preceding each activity. Considerable disruption can be caused by careless sequencing. If subcontractors are scheduled to arrive and work on the project, they will require that the necessary adjoining and substrate work be completed, and they will often leave the job site if this preliminary work is not done. The schedule is a guide and should be changed if the logic is not correct. The logic or proper sequencing is the key to successful projects. All parties involved should review the logic of the project prior to completion of the schedule. So this chart gives an example sequence for the comparison purposes. So for example, there is this sequence 1 and then there is this sequence 2. So this portion of the project involves an addition to an existing gymnasium. The existing building consists of concrete tilt-up wall panels and metal roof joists with a concrete slab on grade. So the existing building has a hardwood gymnasium floor applied above the concrete slab. So the concrete panels at the end of the existing building are to be removed and used as a panels at the end of the addition. The addition of attaches to the existing building and is constructed of tilt-up concrete wall panels and metal joists with a concrete slab or grade similar to the original building. So as a construction manager or a planner for the job, then we may decide that which sequence have to be followed. So both sequence may help to complete the work, but a closer study for this sequence may be needed to select the best thing for that part of the project. So as a closer look at these two sequences show that sequence 1 takes 42 days to complete at a cost of $30,840, but the sequence 2 takes about 1.5 days less and almost $2,000 less to complete. So if both of the sequences are giving us almost similar quantity, and then there are no other constraints in the project, then sequence 2 may be adopted. Some more discussion on the duration of activities. So the activity duration must be accurately predicted. When determining the duration of a construction activity, we can consider these factors. So for example, the duration of an activity needs to be relative to the amount of labor hours included in the estimate. Input from the estimator is often necessary to determine the intended crew size and amount of labor. Construction activities do not always coincide with the estimated items. So some interpretation of the estimated hours is needed. So this information should be combined with the superintendent's view on how the work will be accomplished. The duration of the activity should also relate to the quantity of the work accomplished. It is important to factor crew size against the quantity of the work to be performed. The duration of the concrete form work activities will certainly vary from a situation where there are 2 carpenters and a laborer to 8 carpenters and 4 laborers. So when the crew is properly sized for the project, the productivity rate should not be affected by using a larger crew, but the duration of the activity should be shorter. The activity duration should consider weather concerns in the duration of the activities. The time of the year in which the activity will be accomplished has a large influence on the duration of the activity. So for example, a built-up roofing activity might have a 10 working day duration during warm weather. If this activity was intended to be completed in December in the northern half of the United States, the duration should be longer to allow for weather conditions appropriate for installations without freezing or precipitation. A contractor must allow 20 days during that period, hoping the work would be done within the 20-day window. So another contractor might change the sequence, either completing the roofing prior to November or after March. So normally speaking, we should take weather considerations in our time. Normally, when we are planning for the project, then before putting the activities into the schedule, we don't know that at what time of the year the activity will be performed. So tentatively, an activity time should be selected, and then these activity duration should be put into the schedule, and the schedule will tell us that whether the time of the year will be suitable for the duration of the activity selected. If it is not suitable, then the duration of the activity should be revised in the project schedule. Then the consideration of delivery of all items may affect the duration of the activities. Delivery is a factor in the sequencing of the activity, but it also can affect the duration. And subcontractor involvement in the activity may affect the duration. Duration control can be facilitated by the contractor by ensuring that the crews and the number of crews are available at the proper time. So the contractor cannot easily affect the performance of subcontractors. So some cushion should be allowed in the duration of the subcontractors arriving on the project. So the project schedule is a manifestation of the project plan we are going to discuss. For last thing for the duration of the activities is that the duration in most schedules is expressed in working days, not calendar days. So 5 working days would indicate a week in most cases. For cases on accelerated project phases, the construction week consists of even 7 days. So use of working days for the duration works best, with the project calendar being adjusted for longer work weeks or holidays. So the project schedule is a manifestation of the project plan. It is a written or graphical depiction. The schedule is a communication tool to share the project plan among project participants. It has many forms: a simple non-calculated bar chart, the Gantt chart, a calculated bar chart, a network chart showing interdependencies, sometimes scaled, and tabular schedules listing dates. It should always be remembered that the contractor is trying to communicate one's plan to other participants who are architects, owners, construction managers, subcontractors, and suppliers. So the exact method may vary depending on the target for the information. So a construction manager, for instance, would normally be quite knowledgeable about the schedules and therefore probably would request network reports, tabular reports, and the Gantt chart. The owner, however, may not be interested in reading anything other than the Gantt chart. The contractor should ensure that the appropriate report is given to each party, possibly with additional clarification. Some contractors will send everyone a 3 to 4 inch thick stack of reports, expecting the recipient to discern applicable information. These reports usually are either filed or thrown away without any exchange of information. So, as most scheduling software produce many reports and graphs, there is a tendency to become overwhelmed with the information, losing track of what is important, uh, what is important during construction. So, therefore, we must decide that which party contains, which we should ensure that the relevant schedule should be provided to different parties. So, for example, owners, architect, contractor, subcontractor, supplier. So these parties who are actually actively working on the project may need different types of information on the project. So owner, for example, would be more interested in the completion dates, project and milestones for partial completion. Uh, Owner may also be interested in the current status of the project, problem areas and project changes to dates. Owner may be also interested into the dates and relationships of owner furnished items in separate contracts. Owner may be interested in the current activities in the progress. The owner may be also interested in the schedule for owner provided services such as testing. On the other hand, the architect may be interested into the completion dates, project milestones for partial completion, current status of the project, problem areas and project changes to the dates, relationship of submittal review to construction schedule, because submittal is the process which the architect must look into very carefully. The architect may also be interested into the current activities in the progress, a schedule of inspection, observation, particularly for subcontractors. The contractor, who is the main party doing the work, will be interested into the detailed relationship of the activities, current status of the activities, relationship of project delivery dates for material and equipment for two activities, schedule of subcontract activities for coordination. The contractor may be also interested in the duration of activities to schedule crews. The interrelationship of activities, opportunities to condense construction duration without increasing cost, opportunities to level crew size, and the current activities that are behind or that are expected to exceed their projected duration. The subcontractor may be interested into the expected schedule of particular activities, date required on job site and duration for work, and relationship of other activities that directly affect the subcontract activities, current status of the project, relationship of subcontract material and equipment to activities. So we will continue it in the next video clip.